Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR, Enterprise Core exam. In this lab, we will practice VLAN configurations. This is mostly review from the CCNA, but it is included in the ENCOR exam topics list, and it's worth reviewing to make sure you understand it all. Note that I'm now using CML version 2.5, which was recently released. Finally, you can add shapes and text to the network diagrams. It's kind of amazing it took this long to get basic features like this in CML, but better late than never. Just note that you'll need CML version 2.5 to run the labs now. So this network has 3 VLANs, 10, 20, and 30, and we will make VLAN 20 the native VLAN on trunk links. Generally, it's best practice to not use the native VLAN, but let's get some practice with it. Let's look at the lab instructions. Step 1 says to configure each port on switch 1 and switch 2 in their proper VLANs. It also says to allow only the necessary VLANs on each trunk, and create only the necessary VLANs on each switch. So let's get started. First of all, I'll just configure the access ports on each switch. Switch 1 first. Enable, conft, G02 should be in VLAN 10, and G03 in VLAN 20. Interface G02, I'll configure it as a static access port. Switch port mode access, and then assign it to VLAN 10. Switch port access VLAN 10. Next, G03. Interface G03, switch port mode access, switch port access VLAN 20. Okay, that's it. Switch 2 next. Enable, conft, G01 should be in VLAN 20 and G02 in VLAN 30. Interface G01, switch port mode access, switch port access VLAN 20, then G02. Interface G02, switch port mode access, switch port access VLAN 30. Okay, now let's configure the trunk connection. Since we're on switch 2, I'll start here. Interface G00. Let's make it a static trunk. Switch port mode trunk. As you can see, the command is rejected. That's because these IOSV switches support both ISL and .1Q, so we have to specify the encapsulation type first. Switch port trunk encapsulation .1Q. Now let's try again. Switch port mode trunk. There we go. Now let's check which VLANs are allowed on the trunk. Do show interfaces trunk. All VLANs from 1 to 4094 are allowed by default. Now, only VLANs 1, 20, and 30 are active in the management domain. That's because only those 3 exist, not including VLANs 1002 to 1005. VLAN 1 exists by default, and VLANs 20 and 30 were created when we assigned G01 and G02 to their VLANs. So, should we create VLAN 10 on this switch? No. The instructions said to only create the necessary VLANs. VLAN 10 does not need to exist on this switch to allow connectivity between VLANs. I demonstrated that concept in the lecture video. So let's restrict the VLANs allowed on this trunk link to 20 and 30. VLAN 10 doesn't need to exist on this switch, and it doesn't need to be allowed on this trunk. Switch port trunk allowed VLAN, and let's check the options here. Word allows you to specify the list of VLANs allowed. For example, 20, 30. Let's see. Do show interfaces trunk. Okay, only VLANs 20 and 30 are allowed. What about those other keywords? Add is used to add to the list. All allows all VLANs. Except allows all VLANs except the specified ones. None allows no VLANs. And remove removes the specified VLANs. The big thing to watch out for is that if you want to add or remove a VLAN, make sure to use the add or remove keywords. If you want to, for example, add VLAN 10 to this trunk, let me demonstrate a famous mistake. Switch port trunk allowed VLAN 10. You might think this adds VLAN 10 to the trunk, but let's check. Do show interfaces trunk. So it didn't add VLAN 10 to the list of allowed VLANs. It replaced the list of allowed VLANs with only VLAN 10. So once again, if you want to add a VLAN to the trunk, make sure you use the add keyword. Now the correct configuration for this lab is to allow 20 and 30, so I'll revert back to that. Switch port trunk allowed VLAN 20, 30. Finally, let's configure VLAN 20 as the native VLAN. Switch port trunk native VLAN 20. Remember that the native VLAN is an interface level configuration. It is possible to use a different native VLAN on different interfaces of the switch. Okay, switch 2 is done, so let's go to switch 1 and configure its trunk to switch 2, G01. Interface G01. Switch port trunk encapsulation .1Q. Switch port mode trunk. Next, I'll configure the native VLAN. Switch port trunk native VLAN 20. And let's allow only VLANs 20 and 30. I'll do it in a slightly unconventional way, using the except keyword. Switch port trunk allowed VLAN except 1 to 19, 21 to 29, 31 to 4094. Okay, that should allow every VLAN except the ones I specified, so only 20 and 30. Let's check. Do show interfaces trunk. Okay, only 20 and 30 are allowed. However, there's a problem here. Although VLAN 30 is allowed on the trunk, it doesn't exist on switch 1 yet. That's why it doesn't appear here. Switch 1 doesn't have any access ports in VLAN 30, so it wasn't created automatically. Let's create it. VLAN 30. Now, I'm in VLAN config mode, but VLAN 30 doesn't exist yet. Let me prove that. Do show interfaces trunk. It still doesn't appear here. But now I'll use exit to leave VLAN config mode, and let's check once more. Do show interfaces trunk. There it is. Finally, let's configure G00 as a trunk, since we're going to configure router on a stick in step 2. Interface G00, switch port trunk encapsulation .1Q, switch port mode trunk. This trunk needs VLANs 10, 20, and 30, because hosts in all 3 VLANs will need to access R1 for inter-VLAN routing. So, switch port trunk allowed VLAN 10, 20, 30. And make sure to configure the native VLAN here too. Switch port trunk native VLAN 20. Okay, that's all for step 1. Let's return to the lab notes. In step 2, we will configure R1 to perform inter-VLAN routing with router on a stick. We should configure the first usable address of each subnet as the router's IP address. Okay, I'll go on R1 now. Enable conft. Okay, let's configure 3 subinterfaces on the G00 interface, 1 per VLAN. First, VLAN 10. Interface G00.10. Now, this subinterface number doesn't have to match the VLAN number, but I recommend you make them match. There's no reason not to. Let's specify the VLAN, encapsulation.1Q 10, and the IP address. VLAN 10 is 10.0.10.0/24, so IP address 10.0.10.1, 255.255.255.0. Okay, that's all for VLAN 10. Next up, VLAN 20. Now, VLAN 20 is the native VLAN, so one option is to configure its IP address directly on G00, not a subinterface. But I'll use the subinterface approach. Interface G00.20, encapsulation.1Q20, and add the native keyword to tell R1 that it's the native VLAN. Then the IP address. VLAN 20 is 10.0.20.0/24, so IP address 10.0.20.1, 255.255.255.0. And finally, let's do the VLAN 30 subinterface. Interface G00.30, encapsulation.1Q30, IP address 10.0.30.1, 255.255.255.0. Let's check with do show IP interface brief. Okay, there are the subinterfaces, and they have the correct IP addresses, but they are administratively disabled. To enable them, go to the G00 interface itself, interface G00, and enable it. No shutdown. And let's check again. Do show IP interface brief. Okay, all good now. Since we're here, I want to point one thing out. R1's G01 interface has an IP address that it learned via DHCP, as it says here. It actually learned this from my home router. Let's see the config. Do show run interface G01. There it is, IP address DHCP. To get this to work, I just placed CML's external connector node here, which I renamed to Internet, connected R1 G01 to the node, and enabled DHCP on R1's interface. With that, R1 got an IP address, default gateway, and DNS server setting from my home router. For example, I'll try do ping cisco.com. As you can see, the ping works. It asked the DNS server, my home router, for the IP address of cisco.com, and then sent the ping. So my CML lab is communicating with cisco.com over the internet. Anyway, let's continue the lab. Let's see if our inter-VLAN routing works now that router on a stick is configured. I'll go on PC 1 and try to ping the other PCs. The login is username Cisco and password Cisco. Okay, first I'll try to ping PC 2, which is also connected to switch 1, but in VLAN 20. Ping 10.0.20.10. Okay, the ping works. How about PC 3, which is in VLAN 20, same as PC 2, but connected to switch 2. Ping 10.0.20.11. Okay, this one works too. Finally, PC 4. Ping 10.0.30.10. Okay, looks like inter-VLAN routing works fine. Let's return to the lab notes. Let's do step 3 and step 4 together. Step 3 says to remove the ROAS configuration on R1 and use SVIs on switch 1 for inter-VLAN routing instead. Then, step 4 says to configure the switch 1 R1 link as a layer 3 link, using the 203.0.113.0/30 subnet. There is a note under step 4, which asks which VLAN is assigned as an internal VLAN for switch 1's routed port. You should know the answer already, but we'll confirm after. So first I'll do R1 side. Let's return to R1. First, let's delete the sub-interfaces. To do that, just use no in front of the interface command. No interface G00.10. Then no interface G00.20. Finally, no interface G00.30. Let's check. Do show IP interface brief. Okay, the sub-interfaces are listed as deleted. If I reboot the router, they'll disappear from the output. Now let's configure G00. Interface G00. The instruction said to use 203.0.113.0/30. I'll give R1 the first usable address. IP address 203.0.113.1, 255.255.255.252. Okay, now I will also configure a route on R1. This isn't stated explicitly in the lab instructions, but without a route or routes to the LAN, R1 won't know about the LAN, because it's no longer directly connected to those subnets. Exit. I'll just configure one big summary route to 10.0.0.0/8, but feel free to configure it however you like. IP route 10.0.0.0, 255.0.0.0, then switch 1's IP address will be 203.0.113.2, which I'll configure soon. Okay, that's all on R1. Next, let's configure switch 1's SVIs so it can perform inter-VLAN routing instead of R1. Note that IP routing is enabled on these switches by default, so there's no need to configure that command. Okay, first I'll configure the VLAN 10 SVI. Interface VLAN 10. And let's give it the IP address that was on R1's sub-interface before. IP address 10.0.10.1, 255.255.255.0. SVIs on these IOSV switches are administratively disabled by default, so I'll use no shutdown too. Okay, next up, VLAN 20. Interface VLAN 20. IP address 10.0.20.1, 255.255.255.0. No shutdown. And finally, VLAN 30. Interface VLAN 30. IP address 10.0.30.1, 255.255.255.0. No shutdown. Okay, the SVIs are done. Let's double check that inter-VLAN routing works by doing pings from PC1 again. First, I'll ping PC2. Ping 10.0.20.10. Okay, it works. Next, PC3. Ping 10.0.20.11. This one works too. And finally, PC4. Ping 10.0.30.10. Okay, inter-VLAN routing works fine. Next, let's configure switch 1 side of the switch 1 R1 link. I'll return to switch 1. First, I'll return G00 to the default settings, with default interface G00. Now let's configure it as a routed port. Interface G00, no switch port. IP address 203.0.113.2, 255.255.255.252. Okay, now here's a quiz. Which VLAN is switch 1 G00 using as an internal VLAN? Internal VLANs use the extended VLAN range, from 1006 to 4094. And the default setting is ascending, meaning the switch will assign extended VLANs starting from 1006. So, switch 1 G00 should be using VLAN 1006. Let's check. Do show VLAN internal usage. There it is. VLAN 1006 is being used by G00. To finish up this step, let's configure a default route on switch 1 pointing to R1. Exit IP route 0.0.0.0, 0.0.0.0, 203.0.113.1. Okay, that's all for steps 3 and 4. Let's return to the lab notes. Finally, step 5. It says to configure PAT on R1 to allow the PCs to reach the internet. Currently, the PCs won't be able to reach the internet. To show that, I'll return to PC1. And let's ping Google's DNS server. Ping 8.8.8.8. No output, which means the ping isn't working. Why was R1 able to reach the internet, but the PCs can't? It's because my home router doesn't have a route to any of these subnets, 10.0.10.0, 20.0, and 30.0. When R1 pinged Cisco.com, it sent the ping from its G01 interface, which received an IP from my home router, so my home router knows how to reach it. My home router then used PAT to translate that ping. However, when PC1 tries to ping 8.8.8.8, the ping can reach 8.8.8.8, but my home router doesn't know how to send the reply back to PC1. It doesn't have a route to reach PC1. But if R1 translates PC1's IP address using PAT, PC1 should then be able to reach the internet. Let's try. On R1, I'll do a simple PAT configuration. First, I'll configure the inside and outside interfaces. Interface G00. IP NAT inside. Hopefully, you remember NAT and PAT configuration from the CCNA, but in either case, we'll cover it again in this course. Next, G01. Interface G01. IP NAT outside. Okay, next I just need to configure an ACL to match the PC's source IP addresses, and then enable PAT. Exit. I'll configure a simple standard ACL to match all Class A private addresses. Access list 1, permit 10.0.0.0, 0.255.255.255. That's it. Now I'll enable PAT. IP NAT inside, source list 1, interface G01. Okay, now let's see if PC1's ping works this time. Ping 8.8.8.8. Okay, now it's working. Note that this setup won't necessarily work on your lab. It depends on if R1 is able to get an IP address from your home router via the external connector node. If it doesn't work, you can just replace the internet with another router and configure a loopback interface with an IP address like 8.8.8.8 if you want to replicate this. Okay, we've completed this lab, but we aren't done with VLANs yet in this course. In the next few videos, we'll cover DTP and VTP in greater depth than we did in the CCNA. That's all for this video. Thanks for watching. Before finishing this video, let me thank my JCNP level channel members. To become a member, please click the Join button under the video. Thanks to Jonathan Makara, Velva Jacob, George Streeter, Funny Dart, Nasir Chowdhury, Devin Suku, Gustavo B.R., Gerard Baker, Marcel Lord, Pavel M., Mr. Erlison, Dragos Hernea, Zakib Shah, Mayor Salman, Mason Anderson, Vitaus194, Gina Lindley, Mark Jackson, Bold 1C1U, Michael Carroll, Gerald Guillaume, Gabriel Braga, Hector Hernandez, Maratuba, Roji Kuriakos, Arpad Konives, 5 Feet, Owad, Daniel Brown, Tricky Mickey 123456, Scott Thompson, Jose Alvarez, Kevin Hayes, Hussein Yavuz, Samuel Tavares, Roger Bratseth, Mustafa Irasoy, Nasser Zahar, Brian Grant, Kyle, Georgi Gemejev, Dibia Swain, Arlen Plagaria, Adelson Pereira, Farad69, Lucian Stoichatoyu, Madmark 50484, Sean Powell, Alexandru Stratan, Hiago Bicalho, Abdo Zizo, Piotr Kaimov, Abubakar Berry, Jeremy You Are Really Really Great, Kurt Nell, Preeti Dongave, Omid Farakesh, Steve Cox, Jasper Yim, Wilmer Romero, Enigma G, Laurent Lam, and Emmanuel Nipsido. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So, if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.